The red planet hangs within the frozen velvet of the void as a silent witness to time. Recent orbital data reveals isotopic anomalies, suggesting a past far more complex than previously understood by science. Deep space antennae at the Goldstone complex continue to capture faint whispers from the thin Martian dust. We drift through the ancient history of a world that once mirrored our own blue terrestrial home. The metallic scent of oxidized regolith carries memories of a time when liquid water carved canyons. Scientists observe the seasonal growth of dark streaks on crater walls, which indicate hidden briny flows. This quiet desert world remains a master of secrets held tightly within its basaltic volcanic crust. Every robotic explorer we send across the void adds a small layer to this cosmic puzzle. We must consider the gravity of our curiosity as we peel back the dusty veil antiquity. The silence of the Tharsis volcanoes speaks of a geological heart that beat with immense fire. To understand the present state of Mars, we must first listen to the echoes of past. High-resolution cameras capture the ghost of an ocean that likely covered the vast northern lowlands. Looking closely at the Jezero crater reveals a delta where ancient rivers once deposited heavy silt. Robotic rovers crawl slowly across the orange plains, seeking any microscopic evidence of a biological signature. Our journey toward understanding requires a steady mind and a willingness to accept the vastness time. Every grain of sand on the surface tells a story of atmospheric loss and solar erosion. The cold, thin air vibrates with the soft hum of machines doing the work of humanity. We are small observers, looking out from a pale blue dot at a neighbor of rust. The transition from a wet world to a frozen desert happened over millions of slow years. We find ourselves standing on the edge of a new era of planetary science and discovery. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. The hidden truths of Mars are written in the stones and the shadows of its valleys. Your mind can settle on the horizon as we watch the sunset over the empty plains. We wait for the next signal to arrive from the cold and lonely red desert world. The stars shine brightly above the thin atmosphere of our most mysterious and ancient cosmic friend. The light from the sun takes approximately 12 minutes to reach the rusted plains of the Martian surface. When it arrives, it is a pale, diminished version of the warmth you feel on a summer afternoon. Here, the atmosphere is a thin shroud of carbon dioxide, so delicate that it barely holds the heat of the day. You might imagine standing in the center of a vast, silent basin, where the only sound is the rhythmic, metallic ticking of a cooling rover. The truth about our exploration of this world is found in the pauses between our discoveries. We often speak of Mars as a destination, a target for steel and silicon, yet it remains an elusive phantom. For decades, we have mapped every meter of its topography, yet the most fundamental questions remain unanswered. Why did the water vanish, and where exactly did it go? The current scientific consensus suggests a slow stripping of the atmosphere by the solar wind, a process that lasted for eons. As you listen, let the scale of this transition settle into your mind. There is no rush to find the answers. The planet has waited 4 billion years. It can wait a few hours more. We observe the ripples in the dust, the way they mimic the waves of an absent ocean. We explain them through the physics of low-pressure fluid dynamics. Yet, There is an uncertainty in the timing of the Great Drying. We accept this gap in our knowledge, allowing the mystery to exist without the need for immediate resolution. We move now from the global view to something more familiar, something closer to the ground. Consider the texture of the ground beneath an imagined footstep. It is a surface of ancient basalt, ground down by the relentless movement of wind over spans of time that defy human memory. The silence here is thick, an atmospheric weight that feels like a physical presence. On Earth, silence is rarely absolute. There is always the rustle of a leaf or the distant hum of life. On Mars, the silence is a fundamental property of the geography. It is the sound of a world that has exhaled its oceans and held its breath for an eternity. We look at the smooth, wind-carved stones, known as ventifacts, and we see the patient artistry of the thin air. Each facet on a rock is a record of 1,000 years of sandblasting, a slow and methodical shaping that occurs one grain at a time. There is a particular kind of peace found in the study of a world that moves so slowly. When we look at the high-resolution images of the Martian dunes, we are looking at a landscape that is both dynamic and frozen. The dunes migrate, yes, but they do so with a deliberate, haunting grace. To a human observer, they would appear as still as statues, yet over the decades, our orbital cameras have watched them creep across the floors of craters like dark, slow-moving shadows. This movement is a quiet reminder that even in a place of apparent desolation, there is a rhythm, there is a pulse to the planet, driven by the seasonal sublimation of carbon dioxide ice at the poles, a rhythmic breathing that keeps the dust in perpetual, microscopic motion. The hidden truth of our exploration lies not just in what we have found, but in the humility we have gained. We arrived with the expectation of finding a world that was either dead or alive, but what we found was a world that is geologically brooding. It is a place where the past is not buried deep beneath layers of vegetation or reclaimed by a hungry biosphere. On Mars, the past is laid bare, resting on the surface, waiting for a lens to capture it. We see ancient riverbeds that haven't felt the touch of liquid water since the first multicellular life appeared in Earth's oceans. This preservation is a form of cosmic memory, a library of rocks that tells a story of a solar system in its chaotic youth. We observe the vast northern lowlands, a region so flat and smooth it suggests the floor of a vanished sea. Scientists use laser altimetry to map these basins, finding shorelines that seem to trace the edges of a phantom ocean. We explain this through the hypothesis of a northern paleo-ocean, a body of water that may have once held a third of the planet's volume. Yet, there is a profound uncertainty in how long this water persisted. Was it a stable sea that lasted for hundreds of millions of years, or a series of catastrophic floods that vanished as quickly as they arrived? We sit with this uncertainty, watching the data trickle in at the speed of light, acknowledging that the more we see, the more we realize how much remains hidden beneath the rust. As we descend further into this quiet research briefing, think of the atmosphere as a thin, translucent veil. It is 95% carbon dioxide, a composition that would be alien to our lungs, but is perfectly suited for the slow chemistry of the Martian desert. In the morning, a thin frost of dry ice often coats the rocks, shimmering with a cold, pale light before the sun sublimates it back into a gas. This transition from solid to vapor is silent and invisible, a ghostly change of state that happens every single day. It is a world of transitions, of things becoming other things without the violence of a storm or the rush of a tide. The colors of Mars are a study in subtlety. It is not merely red, it is ochre, butterscotch, dusty rose, and deep charcoal. The red comes from iron oxide rust, which permeates the very air. The planet is literally oxidizing, a slow-burning fire that has turned the surface into a global antique. When you imagine standing there, the sky above you would not be blue, but a soft, salmon pink, the result of fine dust particles scattering the light in a way that is the inverse of our own atmosphere. At noon, the sky is brightest near the sun, and at sunset, the horizon glows with a haunting electric blue. This inversion of the familiar is a gentle reminder of our distance from home. We find comfort in the data. The numbers provided by our landers act as a steady pulse, a heartbeat of information that tethers us to this distant sphere. We know the pressure at the surface is less than 1% of Earth's, a vacuum-like environment where water would boil at the temperature of a lukewarm cup of tea. We understand the physics, the mathematics of the cold, the thermal inertia of the rocks, but the data cannot capture the feeling of the immense, cold sky. It cannot fully convey the weight of the billions of years that have passed since the last great volcanoes fell silent. We use the science to build a bridge, but the bridge leads us into a territory of quiet awe. In this first stage of our journey, we are simply acclimating. We are letting our eyes adjust to the low light and our minds adjust to the deep time. There is no need to rush toward the grand conclusions of life or the destiny of our species. For now, it is enough to simply be an observer of the dust. We are watching the way the shadows of the clouds, thin, wispy cirrus clouds, made of water ice, drift across the slopes of the Tharsis Rise. These clouds move at high altitudes, guided by winds that we are only beginning to map. They are the ghosts of a thicker atmosphere, a reminder that the air still moves, still carries the potential for change. The transitions between the Martian seasons are marked by the movement of these dust clouds. Every few years, a local storm grows, fed by the heat of the sun as the planet reaches its closest point in its elliptical orbit. These storms can grow to encompass the entire globe, wrapping Mars in a shroud that hides the stars for months. Yet, even during these global events, the surface remains strangely calm. The air is so thin that a 100-mile-per-hour wind would feel like a light breeze against your skin. It is a paradox of scale, a global upheaval that carries less force than a summer gale on Earth. We accept this paradox. We accept that Mars is a world of contradictions, a frozen desert that was once wet, a silent world that once thundered with volcanic eruptions, a neighbor that is both intimately familiar and utterly alien. As we move closer to the ground, we begin to see the details, the small, round hematite concretions known as blueberries, the hexagonal patterns in the soil caused by the freezing and thawing of underground ice, and the layers of sedimentary rock that look like the pages of a discarded book. Each layer is a chapter, and we are slowly learning the language in which they were written. The quietude of Section 1 serves as our foundation. It is the baseline from which we will eventually explore the human-scale perspectives and the cosmic continuities. For now, let the image of the orange horizon rest in your mind. The sun is a small, bright coin in the pink sky. The rocks are still. The wind is a faint, rhythmic sigh. We are here, not as conquerors, but as guests of a long and storied history. The mystery of the hidden truth is not a locked door, but a wide, open landscape that we are just beginning to walk across. As the light begins to shift, we prepare to move our focus. We transition from the grand, sweeping vistas of the northern plains to the tangible, physical reality of being on the surface. We move from the global to the local, from the abstract to the concrete. This shift is as natural as the setting of the sun. To understand the hidden truth, we must be willing to look at the smallest grain of sand with the same reverence we give to the largest mountain. We are ready to see Mars, not as a map, but as a place where time has slowed down and where the silence has something very important to tell us, if only we are quiet enough to hear it. If you were to walk across the surface of Mars, your stride would feel light, almost buoyant, as if you were moving through a dream. The gravity is only 38% of what you are used to. A heavy backpack would feel like a light jacket. You could walk for miles across the Meridiani Planum, and the horizon would appear strangely close, curving away from you faster than it does on Earth. Think of the Martian dust, not as dirt, but as a fine, caustic flour. It is everywhere. It is the size of individual smoke particles, drifting into every crevice of our machines. To a rover, a single dune is a mountain range. A small pebble is a significant obstacle. We measure the progress of our exploration in centimeters per second, a pace slower than a garden snail traversing a leaf. There is a quiet humor in the fact that our most advanced technology moves with the deliberate caution of a tortoise. In your mind, compare the vastness of the Valles Marineris to a canyon you have visited. This Martian rift would stretch from New York to Los Angeles. If you stood on one rim, the other side would be lost beyond the curve of the planet. Yet, we explore it one image at a time, one pixel representing a square meter of ancient rock. We are like ants exploring a cathedral, marveling at the architecture without yet understanding the purpose of the design. To truly grasp the scale of the Martian landscape, you must first shrink your perspective to the level of a single footstep. Imagine the weight of your boots pressing into a surface that has not been disturbed for 3 billion years. On Earth, the ground is a living, shifting thing, churned by roots, insects, and the constant cycle of decay and renewal. On Mars, the ground is an archive. Each step you take would be an intrusion into a deep, frozen history. The soil, a fine basaltic silt, would puff up around your ankles in slow motion, settling back down with a gentleness that feels alien to your earthly senses. You are walking on a world where the dust is the only thing that remembers the wind of 1 billion years ago. Consider the simple act of looking at the horizon. On our home planet, the horizon is a distant, hazy suggestion, often obscured by trees, buildings, or the thick moisture of the atmosphere. On Mars, because the planet is smaller and the air is thin, the horizon is sharp, clear, and strikingly close. You might feel as though you are standing on a giant, rusted ball, capable of seeing the very curvature of the world just a few miles ahead. This proximity creates a strange intimacy with the planet. You are not just on it, you are wrapped within its small circular reality. We often think of Mars as a place of grand, sweeping vistas, but the truth of our exploration is found in the mundane. It is found in the way a rover's wheels crunch over a specific type of pebble, or the way the morning sun hits a specific ridge. Scientists back on Earth spend months debating the origin of a single rock the size of a loaf of bread. They give these rocks names of towns, of fictional characters, of ancient explorers, as if naming them makes the vast, indifferent desert feel more like a neighborhood. We take the infinite and we make it small enough to hold in our thoughts. Think of the time it takes for a signal to travel from your mind to the robotic hands on the surface. When a scientist sends a command to move a robotic arm, the light-speed message must bridge a gap of millions of miles. By the time the rover receives the instruction to reach out and touch a stone, several minutes have passed. By the time we see the result of that touch, the sun has moved significantly in the Martian sky. This delay creates a meditative pace to our exploration. We cannot rush. We must wait for the universe to allow the data to return. It is a slow, rhythmic dialogue between two worlds, separated by a sea of vacuum. The hidden truth, often discussed in hushed tones, isn't a secret base or a buried civilization. It is the sheer, overwhelming loneliness of the physics. If you were to stand in the middle of the Gusev crater, the silence would be so absolute that you might begin to hear the internal workings of your own body, the thrum of your blood, the click of your joints. There is no birdsong. There is no rustle of grass. There is only the occasional, low-grade whistle of the thin wind passing over the sharp edges of the rocks. This silence is a scale in itself. It measures the distance between what we know and what we are only beginning to guess. Analogies are the tools we use to stay grounded. We compare the Martian dunes to the Sahara, yet the physics of their movement is entirely different because the air is too thin to lift the sand in the same way. We compare the craters to those on the Moon, yet the Martian craters show signs of ancient water erosion, softened edges that hint at a more temperate past. These comparisons are gentle, imperfect bridges. They help us translate the alien into the familiar, but they always fall a little short. The reality of Mars is always just slightly out of reach, a mystery that retreats as we approach it. The pace of a rover is the pace of deep thought. It moves at about 0.1 miles per hour. If you were walking beside it, you would find yourself constantly stopping, waiting for the machine to catch up. This slowness is intentional. Every centimeter of movement is a risk, a potential encounter with a soft patch of sand that could end the mission. We explore with a caution that borders on the religious. We treat every rock as a sacred text, every grain of dust as a witness to the beginning of the solar system. As you drift deeper into this thought, imagine the Martian night. Without a thick atmosphere to trap the heat, the temperature drops with a sudden, bone-chilling finality. The stars do not twinkle. They are steady, piercing points of light in a sky that is as clear as a diamond. The Earth appears as a bright, blue-tinted star, a tiny spark of life in the immense dark. From that distance, all of human history, all of our triumphs and sorrows, are contained within a single pixel of light. This is the human scale perspective in reverse. We are small, but we are looking. We are tiny, but we are curious. The hidden truth is that we are learning to be still. Mars is teaching us that discovery is not always a sudden breakthrough. It is often the result of quiet, persistent observation. It is the result of looking at the same crater for 10 years until you notice a new streak of dark sand that wasn't there before. It is the patience to wait for the planet to reveal itself on its own terms. We are like students in a vast, cold classroom, and the lesson is about the endurance of matter and the persistence of time. In the Valles Marineris, the shadows are deep and long. They stretch across the canyon floor like dark fingers, marking the passage of the hours. If you were at the bottom, looking up, the walls would rise 4 miles into the sky. You would feel the weight of the planet pressing down on you, a reminder of the tectonic forces that once tore the crust apart. Yet, even here, there is a softness. The edges of the cliffs are blurred by eons of dust accumulation. The violence of the past has been smoothed over by the patience of the present. We are navigating a world of quiet transitions. The transition from light to dark, from heat to cold, from the known to the unknown. As we move through Section 2, let the scale of the canyon stay with you, not as a source of fear, but as a source of calm. There is room in the universe for such vastness. There is room for a canyon that spans a continent, and there is room for our small, curious minds to explore it, one slow, deliberate step at a time. The silence is not an end, it is a beginning. It is the space in which we can finally start to hear the truth. The blue sunset is perhaps the most humanizing element of the Martian day. As the sun sinks, the fine dust in the air scatters the blue light forward, creating a cool sapphire glow around the horizon. It is a moment of profound beauty that feels almost intentional, a reward for the long, dusty day. In that blue light, the red planet feels a little less alien. It feels like a place where one could sit and think. A place where the questions matter more than the answers. We are finding our place in the scale of the cosmos, nestled between the microscopic dust and the infinite rift of the canyon. We will continue to drift through these scales, moving from the human perspective toward the repeating loops of the cosmos. For now, simply rest in the knowledge that the path is long, the pace is slow, and the red world is waiting for us to understand it at our own speed. We begin with the chemical composition of the Martian regolith. When we first landed, we expected simple volcanic ash, but instead we found perchlorates, salts that are toxic to us but lower the freezing point of water. This discovery changed everything we thought we knew about the stability of liquid on the surface. These salts, which act as a powerful antifreeze, mean that even in the bone-chilling cold of a Martian autumn, briny water could theoretically exist in a liquid state, clinging to the underside of rocks or seeping through the top millimeters of soil. It is a strange and quiet truth that the very chemicals that make the soil hostile to human touch are the same chemicals that might allow the planet to hold on to its moisture in the face of a freezing vacuum. The soil of Mars is not a stagnant thing. It is a reactive, chemical skin stretched tight over a body of ancient basalt. When we analyze the dust, we see the results of millions of years of ultraviolet light bathing the surface, unhindered by a thick ozone layer. This radiation breaks apart molecules, creating a landscape that is super-oxygenated. The dirt itself is a slow-burning fire, oxidizing everything it touches, turning iron into the rust that gives the planet its signature hue. We observe this chemical restlessness through the eyes of our robotic explorers, which measure the strange energy of the ground. We explain it as a result of atmospheric loss and solar bombardment, yet there is a lingering uncertainty. We do not fully know if these perchlorates are merely the product of geology and light, or if they are the chemical ghosts of a much older, much more complex cycle. We accept this gap in our understanding, letting the mystery of the soil rest as we move our gaze deeper beneath the surface and into the dark. To understand the hidden depth of Mars, we must look below the fine red flower of the regolith. Beneath the dust lies a world of ice. This is not the ice of a mountain stream, but the ice of an age gone by, preserved in the absolute zero of the subsurface. In the mid-latitudes of the planet, Radar instruments have peered through the dirt to find glaciers that are hundreds of meters thick. These are massive sheets of water, frozen in time and protected by a blanket of soil that keeps them from vanishing into the thin air. We see the shapes of these glaciers in the way the ground slumps and flows, mimicking the movements of frozen rivers. We explain their presence as the remnants of a time when the axis of Mars was tilted differently, allowing snow to fall where now there is only desert. But even with this explanation, a quiet uncertainty remains. We are not entirely sure how much of this ice is pure and how much is mixed with the salts of the surface. We do not know if, deep within the pressurized heart of these glaciers, there might be pockets of liquid brine that have remained wet for 1 billion years. It is a thought that invites a calm curiosity. We accept that there are parts of the Martian interior that remain invisible to us, hidden by the very ground we walk upon. This realization of the unseen ice brings us naturally to the air above, where the planet breathes in rare and unexpected pulses. The atmosphere of Mars is a thin whisper, yet it carries secrets that challenge our understanding of planetary physics. Every so often, sensors on the surface detect a sudden rise in methane gas. On a world as old and cold as Mars, methane should not exist for long. It is quickly destroyed by the sun's rays. Its presence suggests that something, somewhere, is releasing it right now. We observe these plumes as they drift through the Gale crater, appearing with the warmth of the summer and fading as the winter returns. We explain this through the potential of geological reactions, where water meets hot rock deep underground, or perhaps through the release of gas trapped in ancient icy cages. The mystery of the methane is a slow puzzle. It does not demand an immediate answer, but it offers a glimpse into a planet that is still geologically alive in its own subtle way. We do not know if the source is a simple chemical reaction or something more profound. We sit with this question, watching the numbers on the screen and listening to the soft hum of the wind. The uncertainty is part of the landscape. It is as much a feature of Mars as the craters and the plains. This drifting gas leads our eyes upward, toward the horizon and the massive structures that define the Martian sky. We expand our scale once more to consider the mountains that dwarf anything found on Earth. The Tharsis Plateau is a bulge in the planet's crust so heavy that it may have caused the entire globe to tip over billions of years ago. On this plateau sit the shield volcanoes, giants of basalt that rose from the depths when the planet was young and full of fire. Olympus Mons is the greatest of these, a mountain so broad that its base would cover the entire country of France. Its peak reaches so high into the thin air that the sky above it is almost black, even in the middle of the day. We observe these giants through the shadows they cast across the plains, shadows that stretch for hundreds of kilometers as the sun sets. We explain the incredible size of these volcanoes through the lack of moving tectonic plates. On Earth, a volcano moves away from its source of heat, creating a chain of small islands. On Mars, the crust stayed still, allowing the lava to pile up in one spot for hundreds of millions of years. It is a process of immense patience. Yet, even here, there is uncertainty. We do not know for sure when the last eruption occurred. Some lava flows look as though they could be only a few million years old, a mere blink in the eyes of the cosmos. We accept the silence of the volcanoes, moving smoothly from the peaks back down to the quiet, dusty plains where the history of the planet is written in every grain of sand. The expansion of scale from a salt crystal to a continental volcano is a journey of the mind. It allows us to see Mars not as a dead rock, but as a complex system of interlocking mysteries. Each loop of observation and explanation brings us closer to the rhythm of the planet. We see the frost form on the rocks at dawn, and we know it is the same water that once carved the Great Canyons. We see the dust devils dancing across the craters, and we know they are moving the same iron that was forged in the hearts of stars. There is a continuity to it all, a slow and steady progression that requires nothing from us but our attention. As we dwell on these repeating cycles, the density of our questions begins to soften. The need to know every detail is replaced by a gentle acceptance of the vastness. We are small observers in a very large room. The perchlorates will continue their chemical dance, the glaciers will remain in their frozen sleep, and the methane will pulse in the dark. We are part of this expansion, drifting outward from the familiar toward the infinite. The transition is seamless, a natural progression of thought that leads us into a state of deep and quiet reflection. In the silence of the Tharsis rise, the thin air carries the scent of stone and time. There is no sound of life, only the rhythmic ticking of the cooling rocks as the shadow of the mountain grows long. We are learning the language of the desert, a language made of light and shadow, chemistry and cold. It is a slow lesson, one that takes hours to hear and a lifetime to understand. We are in no rush. The planet is not going anywhere, and neither are we. We are simply here, drifting through the loops of the cosmos, watching the red world turn beneath the steady gaze of the stars. The hidden truth is that Mars is a mirror of time. It shows us what happens when a world grows old and quiet. It shows us the beauty of preservation and the dignity of the desert. As we observe the ripples in the dust, we see the echoes of our own curiosity reflected back at us from a world of rust and ice. The scale of the transition is now complete. We have moved from the microscopic to the cosmic, and in doing so, we have found a place of rest. The mystery remains, but it is no longer a burden. It is a companion. We move now into a phase of even deeper drift. The specifics of the chemistry and the heights of the mountains begin to fade into a general sense of presence. The repetition of the Martian day becomes a lullaby. The sun rises in a pink sky and sets in a blue glow. The wind whispers over the basalt, the dust settles. The cycle continues, on and on, through the centuries and the millennia. We are just part of the flow, a quiet broadcast from a distant world, reaching out through the dark to find a moment of peace. Everything is connected by the slow movement of the dust. The same iron that colors the soil of the plains is the same iron that makes up the bulk of the volcanic peaks. It is a world of one color, one texture, and one mood. This uniformity is soothing. It removes the distractions of the manifold earth and leaves us with the essential: space, time, matter, light. We are stripping away the unnecessary until only the planet remains, and the planet is enough. It is more than enough. It is a silent teacher, showing us how to exist in the vastness without fear. The light is dimming now as we conclude this loop. The details of the perchlorates and the glaciers are tucked away in the corners of the mind, where they can rest. We are ready for the next phase of the journey, a phase where the words become fewer and the silence becomes louder. We are moving toward the deep drift, where the mind can finally let go of the need to explain and simply be. The red horizon is waiting. The stars are coming out. The night of Mars is beginning, and it is a night that lasts forever. Moving from the surface minerals, we consider the massive deposits of water, ice buried just inches beneath the red dust. In the mid-latitudes, radar has detected sheets of ice as thick as skyscrapers, remnants of a different climate. These hidden glaciers are not mere anomalies. They are the sleeping reservoirs of a world that was once vibrant with the movement of liquid. To imagine these ice sheets is to imagine a geological memory held in a frozen state, shielded from the sun by a thin, protective layer of Martian soil. This dust acts as a thermal blanket, a dry and dusty shroud that prevents the ice from sublimating into the thin, hungry vacuum of the atmosphere. As we drift further into the subtopic of Martian hydrology, we must observe the subtle clues left on the surface. We see lobate debris, aprons strange, flowing shapes at the base of cliffs that look like the slow movement of Earth's mountain glaciers. On our home planet, these are made of ice and rock, creeping down valleys over centuries. On Mars, they are nearly pure water ice, disguised as heaps of rubble. We explain this through the historical wobbles of the planet's tilt. Unlike Earth, which is stabilized by a large moon, Mars lurches back and forth on its axis over millions of years. When the poles tilt toward the sun, the ice caps vanish and the moisture migrates to the equator, falling as snow and building these skyscraper-thick sheets. Yet, there is a mild, unresolved mystery in the state of this ice. When we look closely with our orbiting spectrometers, we see evidence of seasonal changes that defy simple frozen physics. We see recurring slope lineae, dark, narrow streaks that appear to flow down crater walls during the warmest months. We suspect they are briny seeps, water so heavy with salts that it can exist as a liquid even in the sub-zero chill, but we cannot say for certain. We accept this uncertainty calmly, acknowledging that the transition from solid to liquid on this world is a delicate, ghostly dance. This realization brings us naturally outward, from the buried ice of the craters to the invisible pulses of the atmosphere. Consider the methane that whispers through the canyons. On Earth, methane is a signature of life, a gas that is constantly replenished by the breathing of the biosphere. On Mars, the detection of methane by our rovers is a puzzle of timing and scale. We observe faint plumes that appear near the floor of Gale Crater, rising and falling with a seasonal rhythm that feels almost like the planet is exhaling. We explain this through the possibility of serpentinization, where deep, warm rocks react with water to release gas. It is a geological process, a slow chemical grinding that happens miles beneath the surface. However, the uncertainty remains. Why does the methane disappear so quickly? Current scientific models suggest it should last for centuries in the atmosphere, yet the plumes we detect vanish in a matter of months. We do not know if there is a chemical sink in the dust that destroys the gas, or if our measurements are capturing a localized event we don't yet understand. We move forward with this mystery, allowing the unknown to settle in our minds like the dust settles on a solar panel. The transition from the chemical to the atmospheric is inevitable, leading us toward the grandest structures the planet has to offer. The data continues to stream in from the satellites, recording the steady heartbeat of the magnetic shield. Each vibration is a signal of the Earth's ongoing interaction with the solar wind as it passes by. The heat from the core rises slowly, meeting the energy from the sun that filters down through. This meeting of forces creates a balance, a thermal equilibrium that has lasted for many billions of years. The sensors in the deep crust remain active, listening for the next resonance to move through the rock. We are drifting in the middle of this equilibrium, supported by the heavy mass of the world. The stars above remain fixed in their patterns, even as the invisible environment around us shifts and glows. You can feel the rotation of the Earth as a slow, steady movement that carries us toward tomorrow. The sun will rise, the solar wind will blow, and the magnetic field will continue its protective work. There is a deep, structural integrity to the universe that requires nothing from us but our quiet presence. The loops of energy continue to spiral, the plasma continues to flow, and the planet continues to spin. Everything is, as it has always been, moving in the silence of the great celestial machine. The quiet research briefing concludes its latest chapter, while the instruments remain ever watchful in the high dark. The resonance of the last storm fades into the background noise of the galaxy's long and ancient history. We step back from the monitors and look out at the horizon where the sky meets the Earth. The air is still, the ground is firm, and the stars are waiting for the next slow pulse. One layer leads to another, one scale leads to the next, and the cycle of observation continues. This is the nature of our existence on this blue, wandering sphere. We are observers of a grand and silent machinery that never truly rests, even when the monitors are dimmed and the researchers have gone home. In the high dark of the exosphere, the satellites continue their lonely circular paths, tasting the thin edges of the solar wind. They do not sleep, they only record. They translate the invisible pressures of the cosmos into a steady stream of data, a heartbeat of numbers that confirms the continued resilience of our world. The disturbing discovery of the internal resonance has now been logged, categorized, and woven into the larger tapestry of our understanding. It is no longer a disruption, but a predictable part of the planetary song. Consider the depth of that stillness you feel now. It is a stillness born of incredible speed and immense power, perfectly balanced to create a pocket of peace. While you rest, the Earth is carrying you at 18 miles every second through the solar system. The magnetic field is shimmering, deflecting a torrent of charged particles that would otherwise strip away the very air you breathe. This happens every second, every minute, for every billion years of the planet's life. The superstorm was just a brief moment of intensity in an eternal process of protection. The shield holds, not because it is a rigid wall, but because it is a flexible, living response to the energy of the sun. It is a dance of fields that never ends. The resonance of the storm fades, but it leaves behind a slightly different world. The iron in the core has settled into a new pattern of flow, responding to the magnetic tug of the solar event. The ionosphere has cooled, its atoms returning to their resting states after the excitement of the flare. These changes are infinitesimal on a human scale, yet they are the gears of the world turning. We look at the horizon and realize that the boundary between the here and the there is an illusion of perspective. The sky does not meet the Earth. The Earth is simply the densest part of the sky. We are living at the bottom of an ocean of air, protected by an ocean of magnetism, orbiting an ocean of fire. There is a profound comfort in the repetition of these layers. One layer leads to another. The room you are in is a layer. The house is a layer. The city, the continent, the atmosphere, and the magnetosphere all are nested shells of belonging. Each one is a buffer, a filter that refines the raw energy of the universe into the soft, manageable reality of your daily life. The disturbing realization of our vulnerability is countered by the overwhelming evidence of our stability. The cycle of observation continues because the universe is an inexhaustible source of wonder. There is no final answer, only a series of more beautiful questions. The stars are waiting for the next slow pulse, and so are we. We do not wait with anxiety, but with the calm anticipation of a gardener waiting for the change of seasons. We know the sun will pulse again. We know the magnetic gates will open. We know the core will hum its deep, slow note. And we know that when it happens, the Earth will be ready. The systems that have sustained life through 5 mass extinctions and 1 billion years of geological upheaval are not easily swayed. They are robust. They are ancient. They are certain. As you drift toward the edge of sleep, let the facts of the superstorm dissolve into the feeling of the infinite. The specific mechanics of reconnection and core resonance are just the vocabulary of the cosmos. The underlying truth is the continuity. The universe is a single, unfolding event, and you are a participant in its quiet, steady progress. The air is still, the ground is firm. The pulse of the world is matching the rhythm of your own heart. There is no goodbye in this story, for the story does not end. It merely loops back to the beginning, a cycle of energy and observation that repeats forever. The monitors are dark now, but the reality they tracked continues. The invisible lines of force are wrapping around you, anchoring you to the planet and the planet to the sun. The solar wind is whispering past the magnetopause, a gentle current in the vastness of space. The core is spinning, a heavy, molten anchor that ensures our place in the dark. One layer leads to another. One scale leads to the next. The mystery is revealed, then familiarized, then integrated into the peaceful background of the night. The stars remain. They are the distant markers of our journey, the fixed points in a world that is always in motion. They watch the Earth as it breathes through its superstorms and its quiet minimums. They wait for us to notice the next detail, to uncover the next secret of the magnetic harp. And while we wait, we rest. We rest in the knowledge that the machinery is working. We rest in the certainty of the shield. We rest in the continuity of the cosmic garden. The cycle of observation continues, as steady and inevitable as the turning of the galaxy itself. Everything is moving exactly as it should. The energy flows, the field holds, and the world is at peace. The resonance fades, the horizon stays, and the high dark remains watchful. There is only the drift, there is only the pulse, there is only the infinite, quiet, and enduring life of the spheres. To understand the cosmos, we first have to understand our own limitations. We evolved to perceive distances we can walk in a day, or see with our own eyes distances that matter for survival and navigation. A kilometer is a 10-minute walk. A mile is a 20-minute journey. These measurements are concrete and relatable because they fit into our daily lives. But the moment we look up, these human-scaled units become awkward and eventually useless. To explore the universe, we must leave behind the familiar and prepare for a scale that challenges our very ability to comprehend it. Our brains are essentially biological survival machines, fine-tuned over millions of years to solve problems on a local scale. When our ancestors stood on the African savanna, big meant the distance to the horizon or the height of a mountain. Fast was the speed of a sprinting predator or a falling stone. We developed a deep, intuitive relationship with the physical world, but it was a world restricted to a very narrow band of reality. This is our human-scale anchor. It is the comfort zone of the tangible. In this zone, we can estimate how long it takes to drive to the next city, or how many steps it takes to cross a room. We feel the weight of an object in our hands and know its mass. This grounding is necessary for life on Earth, but it acts as a mental barrier when we attempt to look beyond our atmosphere. Consider the humble meter or yard. These units are literally based on the human body, the length of a stride or the reach of an arm. When we use these units to measure a house or a street, they make perfect sense. Even when we scale up to the size of our planet, we can still, with effort, visualize it. We can imagine a flight across the ocean taking 12 hours, and our brains can loosely stitch together that duration with the physical distance covered. We can look at a globe and understand that the thin blue line of the atmosphere is fragile, but even at this stage, the anchor begins to drag. The Earth is roughly 12,742 kilometers in diameter. If you were to try to walk that distance without stopping, it would take you months of continuous movement. Already, the human scale is beginning to fray at the edges. The problem is that the universe does not operate on a human scale. It operates on a cosmic one. As soon as we leave the surface of our world, the numbers don't just get larger, they change in quality. They become abstract. When we say the moon is 384,400 kilometers away, the brain hears the number, but it cannot feel the distance. It loses the tactile connection it has with a kilometer-long walk. This is the lunar gap, the first true test of our ability to let go of our terrestrial anchors. To bridge this gap, we often use analogies, telling ourselves that you could fit 30 Earths in the space between us and the moon. We use these mental crutches because the raw data is too vast for our ancestral hardware to process. We are trying to run cosmic-scale software on hunter-gatherer hardware. This limitation isn't just a quirk of psychology, it's a fundamental challenge in how we communicate the story of space. If we cannot relate to the distance of our nearest neighbor, how can we hope to grasp the distance to the sun? The sun is 150 million kilometers away. At this point, the kilometer has become a redundant tool. Using it to measure the solar system is like trying to measure the width of the Atlantic Ocean using the thickness of a human hair. It is technically possible, but the resulting number is so large that it ceases to mean anything to the human mind. This is why we must transition into new units of thought. We have to learn to think in terms of light-time understanding that even at the fastest speed allowed by the universe, it still takes 8 minutes for a photon to travel from the sun to your eyes. By anchoring ourselves in the human experience first, we acknowledge our starting point. We admit that we are small, that our perspective is local, and that our intuition is often wrong when applied to the stars. This humility is the prerequisite for discovery. We must accept that our senses were never designed to perceive the curvature of space-time or the billion-year life cycles of stars. We are effectively scale blind. Just as a person born without the ability to see color must rely on instruments to tell them the sky is blue. We must rely on mathematics and technology to tell us the true dimensions of the void. The human anchor is also about time. We live for perhaps 80 or 90 years. To us, a decade is a significant portion of our existence. A century is ancient history. But in the cosmic script, a million years is a blink. The stars we see at night are not static. They are in violent, constant motion. But because their lives span billions of years, they appear frozen to our short-lived eyes. Our anchor in time is just as restrictive as our anchor in space. We view the universe as a still photograph, when in reality it is a chaotic, high-speed film. To understand space-themed stories, we have to mentally speed up our perception of time while slowing down our expectation of distance. Every story we tell about the stars is an attempt to pull the cosmos down to our level. When we talk about interstellar travelers or galactic empires, we are using human political and social structures to make the infinite feel intimate. We give names to constellations, warriors, queens, and animals to turn a terrifyingly vast vacuum into a familiar neighborhood. This is a necessary survival mechanism. Without the human anchor, the sheer scale of the universe would be paralyzing. It would be a total perspective vortex that could crush the human spirit under the weight of its own insignificance. But there is a beauty in this struggle. The fact that a creature whose world is measured in footsteps can calculate the mass of a black hole or the age of a distant galaxy is a testament to the power of the mind to transcend its biological limits. We are anchored to the Earth by gravity and to our history by evolution, but our curiosity is unanchored. We use the familiar, the walk, the mile, the minute as a springboard to leap into the unfamiliar. We build mental ladders, starting with the human scale and slowly adding rungs of increasing magnitude until we can reach the stars. As we move forward into the deeper segments of the cosmic story, keep this anchor in mind. It is your point of reference. Every time we speak of a distance that breaks the brain, remember that it only breaks the brain because the brain was built for the forest and the field, not the vacuum. By recognizing the boundaries of our internal map, we can finally begin to explore the territory that lies beyond the edges. We are the bridge between the microscopic and the macroscopic. We are the observers who give the scale a name. In the following segments, we will leave the shore of the familiar. We will watch the Earth shrink until it is nothing more than a pale blue dot, and then we will watch that dot vanish entirely. We will see structures so large that they defy the cosmological principle, and we will encounter anomalies that suggest our current maps are incomplete. But no matter how far we travel, we always carry the human anchor with us. It is the "you are here" marker on the map of the infinite. It is what allows us to say, "I am small, but I am here, and I am looking." This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And, more importantly, where do we fit in? The journey starts here with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. To begin this expansion of our perspective, we must look at the tools we use to hold on to our reality. Think about your home. The average house is a space you can walk across in 30 seconds. You know the texture of the walls, the creak of the floorboards, and the exact distance from the front door to the kitchen. This is your primary anchor. It is a scale that makes perfect sense to your brain because you experience it every second of every day. Your brain evolved to understand these immediate, tactile spaces, areas you can see, touch, and navigate without a second thought. But when we move from the living room to the city, the anchor begins to slip. We start relying on technology, like cars and maps, to bridge the gap between what we can see and where we need to go. We are already abstracting our reality. The problem is that the leap from a city to a planet is nothing compared to the leap from a planet to the void. Imagine standing on a football field. It's about 360 feet long, a distance you could stroll across in 2 minutes. Now, imagine laying 17 of those fields end to end. That is a mile. Comet. Kea. A mile is a distance most of us can still visualize. It's a 20-minute walk, a common measurement for a morning jog. But to reach the edge of our own atmosphere, you would need to stack 62 miles of those football fields vertically. This is the Kármán line, the invisible boundary where the sky turns to space. Even at this relatively short distance, our human intuition fails. We cannot see 62 miles up. We only see a blue haze that fades into black. This brings us to the lunar gap. The moon is our closest neighbor, sitting approximately 238,855 miles away. To a human brain, that number is just a digit on a page. To bring it back to the anchor, consider this. If you could drive a car at highway speeds toward the moon, it would take you nearly 6 months of non-stop driving to get there. No red lights, no gas stations, just 160 days of driving through a vacuum. If you chose to walk, it would take you 9 years. This is the first rung on the cosmic ladder where the human scale starts to feel absurd. We use these analogies like fitting 30 Earths between us and the moon, not because they are scientifically precise, but because they are the only way to prevent our minds from shutting down in the face of such emptiness. Once we pass the moon, the anchor is no longer dragging, it is severed. The distance to the sun is 93 million miles. This is the solar anchor, the unit we call an astronomical unit, AU. If the moon was a 9-year walk, the sun is a walk that would take you 3,500 years. You would need 40 generations of your descendants to keep walking just to reach the light. This is why we stop using miles and start using light time. Light is the fastest thing in the universe, traveling at 186,000 miles per second. It can circle the Earth 7 times in a single heartbeat. Yet, even at this impossible speed, it takes light 8 minutes and 20 seconds to reach us from the Sunday. When you look at a sunset, you are seeing the sun where it was nearly 9 minutes ago. You are already looking into the past. This temporal shift is a crucial part of the human anchor. We are used to things happening now. If you drop a glass, it breaks now. If you call a friend, they hear you now. But in space, now is a localized concept. The further out we look, the further back in time we see. This creates a strange paradox. The larger the universe gets, the older the information we receive becomes. By the time we look at the nearest star system, Proxima Centauri, we are looking 4 years into the past. If that star were to vanish today, we wouldn't know for another 4 years. We are anchored in a present that doesn't exist for the rest of the cosmos. To understand the scale of a galaxy like our Milky Way, we have to stretch the anchor until it breaks. Our galaxy is 100,000 light-years across. If you were to scale the entire Earth down to the size of a single grain of sand, the Milky Way would still be the size of the entire United States. Think about that for a moment. Every mountain, every ocean, every city, and every person who has ever lived, all shrunk into one speck of sand, and the neighborhood it lives in is still a continent wide. This is the true scale that makes Earth disappear. We aren't just small, we are mathematically insignificant in terms of volume. And yet the Milky Way is just a mid-sized galaxy. When we look at giants like IC 1101, which is 6 million light-years across, the Milky Way itself becomes the grain of sand. IC 1101 is so large it could swallow thousands of Milky Ways. It is a cosmic monster, a graveyard of galaxies that have been consumed over billions of years. At this scale, the human anchor is so far behind us that it's almost impossible to find. We are talking about structures that take millions of years just for a single particle of light to cross. If you were on one side of IC 1101 and sent a hello message to the other side, by the time it arrived, your entire species might have evolved into something else or vanished entirely. But why does this matter to us, the observers? It matters because it defines the cosmological principle, the idea that on a large enough scale, the universe looks the same everywhere. But our recent discoveries of defiant anomalies suggest this might not be true. We have found structures like the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure is so large it shouldn't exist according to our current models of how the universe grew. It is a knot in the fabric of space that defies the smoothness we expected. These are the things that keep astronomers awake. They are the moments where our mathematical anchors fail, and we realize that the universe is even stranger than we imagined. We also encounter interstellar visitors like 3I, Atlas, or Oumuamua objects that don't belong to our sun. They come from the dark, silent reaches between stars, carrying secrets of other worlds. When we see these objects, the human anchor feels a different kind of tug. It's not just about size, it's about loneliness. We look at these drifting rocks and wonder if they were once part of a system like ours, or if they are the cold spots of a distant, dying sun. They remind us that our solar system is not a walled garden, but a porch light in a very dark forest. The human anchor is also a shield against the vast empty. Between the galaxies lie the voids, spaces, millions of light years across, where there is almost nothing. No stars, no planets, just a few stray atoms per cubic meter. If you were placed in the center of the Boötes void, you wouldn't see a single star in the night sky. It would be total, absolute darkness in every direction. For a creature evolved to follow the sun and the moon, this kind of emptiness is a sensory nightmare. Our anchor helps us populate that darkness with meaning. We look at the Great Attractor, a mysterious gravitational anomaly pulling our entire region of space toward it, and we give it a name. We turn a terrifying physical force into a character in our cosmic story. Consider the smallness of our achievements. We have sent probes like Voyager 1 into the interstellar medium. It has been traveling for nearly 50 years at 38,000 miles per hour. In human terms, that is incredibly fast. In cosmic terms, it hasn't even left the front yard. It will take Voyager 40,000 years to reach the vicinity of another star. This is the reality of the distance that breaks our brains. We are a species that lives for decades, trying to conquer a universe that operates in eons. However, there is a flip side to this insignificance. If the universe is so large and we are so small, then the fact that we can understand it at all is a small miracle. We are an arrangement of atoms, carbon, nitrogen, oxygen forged in the hearts of dying stars. We are literally stardust that has come together in such a complex way that it can now turn around and study the stars that made it. The universe is looking at itself through our eyes. When we calculate the distance to a quasar or the mass of a supermassive black hole, we are the universe's way of knowing itself. The human anchor isn't just a limitation, it's a perspective. Without the anchor, size has no meaning. A galaxy is only big because we know what small feels like. The vacuum is only empty because we know what a crowded city street feels like. We provide the contrast. We are the yardstick by which the infinite is measured. Every space-themed story, whether it's about a journey to Mars or the collision of two galaxy clusters, is ultimately a story about us. It's about how our human hearts react to the cold, beautiful indifference of the stars. As we continue to explore, we must be prepared for our anchors to be tested again and again. We will find impossible stars that are older than the universe itself. We will hear strange signals from the deep that might be natural or might be something else. We will see giant circles in the sky that hint at events from before the Big Bang. Each time, we will try to drag our human-scale units, our kilometers and our miles out into the deep to make sense of it. And each time, they will fail us, forcing us to grow, to adapt, and to build a bigger anchor. The human anchor is our starting point, but it is not our destination. It is the solid ground we stand on before we take the leap. We must respect our limitations, but we must never be imprisoned by them. We are the bridge builders. We bridge the gap between the grain of sand and the galaxy. We bridge the gap between the 10-minute walk and the billion-year journey. So, as we move into the next segments of this general script, as we look at the true scale, the light years, and the anomalies, remember the anchor. Remember the smell of rain on pavement, the warmth of the sun on your skin, and the simple reality of a 1-mile walk. Hold those things close. They are what make the vastness of space worth exploring. They are the reason we look up in the first place. We don't go into the dark to get lost. We go into the dark to find out just how bright our own small light truly is. We have grounded ourselves. We have acknowledged our size. Now we are ready to leave the shore. The horizon is calling, and though it is further than it looks, we have everything we need to begin the crossing. The universe is vast, but it is also ours to observe. And that, in the end, is the most human anchor of all. When we think about the solar system, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. We look at a map of the planets, and our brains instinctively try to shrink the cosmos down into something manageable, something that fits on a kitchen table or a classroom poster. But the reality is that the solar system is not a collection of objects. It is a collection of distances. It is an exercise in emptiness, punctuated only occasionally by the smallest specks of matter. To understand where we are, we have to first understand how much where there actually is. Imagine, for a moment, that you are going for a walk. You know the weight of your footsteps on the pavement. You know how long it takes to walk to the end of your street or to the local park. If you walked at a steady, brisk pace for an entire hour, you would cover about 3 miles. In our daily lives, 3 miles is a substantial distance. It is enough to change the scenery, to move from a busy downtown to a quiet suburb. But in the context of the solar system, that hour of walking hasn't even moved you the width of a single hair on the scale of the worlds we are about to discuss. To truly grasp the human scale perspective, we must use an analogy that strips away the confusing billions of miles and replaces them with things you can visualize. Let us use the grapefruit analogy again, but let's walk through it slowly, feeling every step of the journey. Imagine you are standing in the center of a vast, empty salt, flat, level ground, stretching to the horizon in every direction, silent and still. In your hand, you hold a grapefruit. This grapefruit represents the Sunday. It is warm, it is bright, and it represents 99.8% of all the matter in our entire solar system. Everything else, the planets, the moons, the asteroids, and you make up that tiny remaining 0.2%. Now, place that grapefruit on a small pedestal in the center of the salt flat. To find the Earth, you have to start walking. You aren't just stepping back a few feet. You walk past the first planet, Mercury, which is a tiny pinhead just 5 yards away from the grapefruit. You keep walking another 5 yards to find Venus, another pinhead. Finally, you reach a distance of about 15 yards, roughly the length of a large school bus, and you stop. There, on the ground, you place a single grain of salt. This is Earth. This grain of salt is your home. Everything you have ever known, every person you have ever loved, every war ever fought, and every dream ever dreamt has occurred on that tiny, crystalline speck sitting 15 yards away from a grapefruit. The first thing that strikes you in this silence is the space. Look back at the grapefruit. From the perspective of your grain of salt, the grapefruit looks small. It's about the size that the actual sun appears in our sky. But look at the ground between you and the grapefruit. There is nothing there. No cosmic dust clouds, no crowded asteroid fields. Just 15 yards of empty air. If you were an ant standing on that grain of salt, the distance to the grapefruit would seem like an infinite journey. Now, let us continue our walk. We want to find the outer reaches of the neighborhood. To reach Mars, the red pinhead, you walk another 7 yards. You are now 22 yards away from the Sunday. The distance is growing, and the grapefruit is looking smaller now. But we are still in the inner circle. To find the next planet, Jupiter, you have to be prepared for a hike. You leave the inner planets behind and start walking across the salt flat. You walk past the 30-yard mark, the 40-yard mark. You keep going until you are nearly 80 yards away from the grapefruit, almost the entire length of a football field. There, you find a cherry tomato. This is Jupiter, the king of the planets. Even though it is the largest planet, compared to the grapefruit, it is still just a small piece of fruit, and the distance between your grain of salt and this cherry tomato is 65 yards of absolute nothingness. As you stand by the cherry tomato and look back toward the center, the grapefruit is now a small dot in the distance. Your home, the grain of salt, is invisible to the naked eye. You are beginning to feel the true scale. But we aren't finished. To reach Saturn, you have to double your distance again. You walk until you are 140 yards away from the grapefruit. To reach Uranus, you walk to 280 yards. By the time you reach Neptune, the final major planet, you are nearly 450 yards away, more than a quarter of a mile from where you started. Stand there for a moment at the Neptune marker. You are a quarter mile away from a grapefruit. If you look back, you cannot see the grain of salt that is Earth. You can barely see the grapefruit. The solar system that we see on posters as a crowded family of planets is, in reality, a vast, lonely desert where the participants are so small and so far apart that they almost don't exist. This challenges how we think about our place in the world. We feel big, we feel important, but on the scale of the grapefruit and the salt flat, we are essentially a ghost. The silence of this perspective is not meant to make you feel insignificant in a negative way. Rather, it is meant to provide a sense of profound relief. All of the pressures of your daily life, the deadlines, the worries about the future, they all exist on that grain of salt. And that grain of salt is safely tucked away in a corner of a quarter-mile wide field of peace. Scientists understand this scale, not just through distance, but through time. If you wanted to send a message from your grain of salt to the cherry tomato of Jupiter using light, the fastest thing in the universe, it would take about 40 minutes for the message to arrive. If you were Neptune and you wanted to call Earth, you would have to wait 4 hours for your hello to reach home and another 4 hours for the reply. The solar system is a place where even conversation happens in slow motion. What makes this strange is not the distances themselves, but the fact that gravity manages to hold it all together. That grapefruit, all the way back at the center, is pulling on the speck of dust that is Neptune nearly half a mile away, with enough strength to keep it in a perfect, steady circle. It is a delicate, invisible clockwork. As you imagine yourself standing on that salt flat, the sun beginning to set, the grapefruit glowing faintly in the distance, you can feel the air grow still. You are a human-scale observer in a cosmic-scale reality. You are small, yes, but you are the only thing in this quarter-mile radius that is capable of understanding the map. You are the mind that holds the grapefruit and the salt grain together. For now, that understanding is enough. You don't need to walk any further tonight. You can simply stand here, in the quiet of the salt flat, and realize that the scale of the universe is not a wall, but an invitation. It is an invitation to let go of the small things and embrace the vastness. With that in mind, let's move outward once more to an even larger scale. This is where the human brain begins to feel the first gentle tug of the impossible. We have spent our lives navigating a world where a 5-mile hike is a morning's commitment and a cross-country flight is a significant journey. But as we step away from our grain of salt and our grapefruit, we have to abandon these units of measurement. They no longer serve us. They are like trying to measure the depth of the ocean with a thimble. To move forward, we must change our pace, transitioning from the physical act of walking to the mental act of drifting. Think about the speed of a commercial airliner cruising at 500 miles per hour. At that speed, you can cross an entire continent in an afternoon. It feels fast. You look out the window and see the clouds racing by, the landscape shifting beneath you. But if you were to fly that same plane from our grain of salt toward the sun, you wouldn't arrive for 21 years. You would spend 2 decades in the air, flying day and night just to reach the nearest star. This realization is the first scale reset. It forces us to acknowledge that the empty space we often ignore is actually the most dominant feature of our environment. As we continue to expand our perspective, we encounter the first major boundary of our planetary neighborhood. In our everyday lives, we are used to boundaries that are clear: a fence, a shoreline, a city limit. In space, boundaries are more like gradients, where the influence of one thing slowly fades as the influence of another begins to take hold. We are moving toward a scale where the gaps between objects are so large that the objects themselves start to feel like accidental interruptions in a much larger story of stillness. Consider the moon, our closest neighbor. In most diagrams, it sits just a few inches away from the Earth. But on our human scale, if the Earth were a basketball, the moon would be a tennis ball located 30 feet away. Think of that empty 30-foot gap. You could fit every other planet in the solar system: Jupiter, Saturn, the ice giants, all of them, side by side, inside that single gap between the Earth and the moon, and you would still have room to spare. This is the lunar gap, and it is our first true lesson in cosmic density. We live in a universe that is incredibly efficient at being empty. As we drift further, the numbers begin to lose their edges. We talk about millions of miles, but the human mind treats a million the same way it treats a billion as a lot. To stay grounded, we must return to the feeling of time. Imagine a clock that ticks only once every century. On the scale we are entering, that clock would seem to be moving quite fast. The solar system operates on a rhythm that ignores the frantic pace of human history. The mountains on our grain of salt rise and fall in the time it takes for the outer planets to make just a few laps around the Sunday. Scientists understand this slow-motion reality by looking at the human-scale anchors that still exist within it. We look at the light that reaches us from the Sunday. That light, traveling at 186,000 miles per second, takes 8 minutes to cross the 15 yards of our salt-flat model. When you step outside and feel the warmth of the sun on your skin, you are feeling energy that left its source 8 minutes ago. You are always living in the past, seeing the sun not as it is now, but as it was when you were perhaps just starting a conversation or finishing a cup of tea. This delay is a constant reminder that distance and time are woven together. What makes this strange is not that the universe is big, but that it is so sparsely populated. We are used to a world of constant stimulation noises, lights, people, traffic, but as we expand to the scale of the inner solar system, the stimulation drops to nearly zero. If you were floating in the space between Earth and Mars, there would be no sound, there would be no wind, there would be no sense of movement, even if you were traveling at thousands of miles per hour. Without a nearby object to provide context, speed becomes an abstract concept. You are simply there, suspended in a vast, dark cathedral of light. Astronomers didn't expect the vacuum to be quite so profound until they began sending probes across these distances. They found that space isn't just empty. It is a vacuum more perfect than anything we can create in a laboratory. It is a place of total preservation. A footprint on the moon stays there for millions of years because there is no weather to wash it away. The scale of the solar system is also a scale of permanence. On Earth, we are used to things breaking, rusting, and fading. In the vastness between the worlds, things simply endure. And for now, that endurance is simply part of the picture. It provides a sense of stability. As you continue to drift in your mind, let the vastness of these gaps act as a blanket. There is so much room in the universe for everything to simply be. There is no crowding here. There is no rush. Every planet has its own vast territory, millions of miles of private space in which to perform its slow, ancient dance. We often feel the need to fill silence with words or empty spaces with objects. But the solar system teaches us the value of the void. The void is not a lack of something. It is a thing in itself. It is the stage upon which the planets play. It is the dark velvet that makes the stars shine. By embracing the human-scale perspective of this emptiness, we can begin to let go of our own need to constantly be doing. We can transition from being actors to being observers. To understand the scale of the outer system, we need to step back even further. If our quarter-mile salt flat represented the distance to Neptune, the distance to the next nearest star, Proxima Centauri, would be another 2,000 miles away. Imagine that. You have a grapefruit in one city, and the next grapefruit isn't in the next neighborhood or the next town. It's on the other side of the continent, and in between, nothing. Just thousands of miles of empty salt flats, with the occasional grain of salt or cherry tomato drifting in the dark. This challenges how we think about the neighborhood of our Sunday. We aren't just in a large space, we are in a staggering isolation. But this isolation is what makes our small grain of salt so remarkable. In a continent of empty flats, a single grain of salt that holds life, water, and consciousness is a miracle of the highest order. The scale doesn't diminish us, it highlights us. It provides the contrast necessary to see how special the stuff of the universe really is. As we move toward the next phase of our journey, allow your breathing to slow down, matching the rhythm of the planets. You are no longer walking. You are no longer flying, you are simply expanding. The boundaries of your room have faded. The boundaries of your city have disappeared. You are now as large as the orbit of the Earth, circling the Sun in a slow, silent loop that takes an entire year to complete. There is no tension in this movement. It is the natural state of things. Everything in the solar system is falling, but it is falling in a way that perfectly balances its forward motion, creating the eternal circle of the orbit. It is a state of perpetual grace. You can feel that same balance in your own rest. You are supported. You are in motion, even when you are still. You are part of the clockwork. With that in mind, let's move outward once more, to an even larger scale, where the rocky worlds end and the giants begin. Where the light grows dim and the silence grows even deeper, we are leaving the inner circle, the warm hearth of the sun, and moving into the great, cool expanses of the outer dark. But do not worry. The scale will continue to guide us. The distances will continue to protect us, and the stillness will be our companion. Now let's slowly expand outward. One level beyond what we just explored lies the neighborhood of the inner planets: Mercury, Venus, Earth, and Mars. In the grand design of the cosmos, these are the rocky worlds. They are solid. They have surfaces you could, in theory, stand upon. They represent the high-density center of the sun's domain, a place where the gravity of our star is so intense that it has cleared away the lighter gases, leaving behind only the heavy elements, the iron, the silicate, and the nickel, to form these 4 small, resilient spheres. To understand the inner circle, we must first look at Mercury. It is the closest to the flame. If our sun is the center of a cosmic hearth, Mercury is the stone sitting directly in the embers. It is a world that has been stripped down to its essentials. It has no atmosphere to speak of, no clouds to shield it from the sun's relentless gaze. Because it lacks an atmosphere to trap heat, it experiences the most dramatic temperature swings in the solar system. By day, the surface is hot enough to melt lead. By night, it plunges into a frozen darkness more bitter than any winter on Earth. Scientists understand Mercury by observing the way it interacts with the sun's magnetic field. It is essentially a giant ball of iron, a planetary core that seems to have lost its outer layers in some ancient, forgotten collision. It orbits the sun with a strange, wobbling rhythm, completing 3 rotations for every 2 revolutions. It is a world that refuses to be tidally locked, yet it is forever bound to its master. As you consider these 50 or so stars nearby, let your mind drift away from the details. Imagine them as small, steady lanterns hanging in a very large, very dark room. They are far apart, they are mostly dim, and they have been there for billions of years. They are the first step on a journey that will eventually take us to numbers that break the brain. But here, in the neighborhood, the lights are still few enough to count, if you have the time. With that in mind, let's move outward once more, to an even larger scale. As we drift further away from the familiar warmth of our sun, we begin to realize that the neighborhood is far more crowded than it appears, yet far emptier than we can imagine. We are leaving behind the terrestrial measurements of miles and kilometers, entering a realm where the only meaningful yardstick is the light year, the distance light travels in a single Earth year, roughly 6 trillion miles. To understand the number of stars nearby, we must first accept that our eyes are only tuned to the high-performance engines of the cosmos. We see the giants, the burners, and the beacons, but the true census of our local space is written in the dim, the small, and the patient. When we look out into the 16 light years surrounding our home, we find a curious demographic. We expect to see stars like our sun, yellow, vibrant, and life-giving. But of the 50 or so stars in this immediate vicinity, the vast majority are red dwarfs. These stars are the introverts of the universe. They are often less than half the size of our Sun and significantly cooler. If our Sun is a roaring bonfire in a dark forest, a red dwarf is a single glowing ember. This brings us to a staggering realization about the count. The universe is not made of the bright things we see, but of the dim things we overlook. Scientists understand the prevalence of these stars by using infrared surveys, peering through the cosmic noise to find the heat signatures of these small suns. What we know so far suggests that for every star that makes it into our mythology and our constellations, there are 10 more that are too shy to be seen. In our local neighborhood, this means that even if you had a telescope in your backyard, most of your neighbors would remain invisible to you. They are there, huddled in the dark, burning their fuel so slowly that they will still be shining long after our Sun has expanded into a red giant and faded into a white dwarf. But the count doesn't stop with the stars that successfully ignite. One level beyond the red dwarfs lies a category of objects that challenges our very definition of what a star is: the brown dwarfs. Often called failed stars, these objects are the middle ground between a massive planet like Jupiter and a small star. They are too heavy to be planets, but too light to sustain the nuclear fusion that allows a star to shine with its own light. Astronomers didn't expect to find so many of these objects drifting through the solar neighborhood. They move through the dark like rogue wanderers, glowing only with the leftover heat of their formation. Because they are so difficult to detect, the actual number of objects in our neighborhood might be double or triple what we currently estimate. Every time we launch a new, more sensitive space telescope, we find more of these dim travelers. What makes this strange is not what we see, but what we don't understand about their distribution. Are they as common as the stars themselves? Do they outnumber the planets? To understand why the number of stars breaks the brain, we have to look at the density, or rather, the lack of it. Even with 50 stars and potentially hundreds of brown dwarfs within 16 light-years, the volume of space they occupy is so immense that they almost never interact. Imagine a volume of space so large that light takes 30 years to cross it from end to end. Now, imagine placing 50 marbles inside that space. The chances of one marble ever meeting another are practically zero. This is the isolation of the solar neighborhood. We are a collection of islands in a sea of nothingness. Scientists use the motion of these nearby stars to calculate the mass of the galaxy, but for the individual stars, the neighborhood is a place of profound solitude. Proxima Centauri, our closest neighbor, is part of a triple star system, a rare social gathering in a lonely sector. But even there, the distances between the 3 stars are vast enough that if you lived on a planet orbiting one, the others would still be mere points of light in your sky, not secondary suns that would warm your skin. Even with everything we've learned through missions like Gaia and WISE, there are still things we don't fully understand. We are still uncovering substellar objects that sit right in our backyard. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time, and it hides its smallest residents well. We may find that the number of stars in our neighborhood is actually much higher, populated by cool, dark suns that have been there since the beginning of the Milky Way, waiting to be noticed. And for now, that uncertainty is simply part of the picture. We don't need a final tally of every brown dwarf or dim red dwarf to appreciate the scale. The mystery itself provides a sense of continuity. It suggests that even in the parts of space we think we know best, there is more to be discovered. It doesn't need to be resolved tonight. As we rest in the knowledge of our local street, this small, quiet, suburban neighborhood of 50-odd suns and their invisible companions, we prepare our minds for the next leap. We have counted the houses on our street. Now, it is time to look at the city. We are moving from the dozens to the billions. We are moving from the neighborhood to the galaxy. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond our solar neighborhood lies the entirety of the Milky Way galaxy. If our local neighborhood was a single street, the Milky Way is the sprawling, glowing metropolis that contains it. Our galaxy is a barred spiral, a massive whirlpool of stars, gas and dust spanning 100,000 light-years from edge to edge. To traverse it at the speed of a commercial airliner would take you more than 100 billion years, a duration that exceeds the age of the universe itself. Inside this vast structure, the numbers begin to lose their grip on our intuition entirely. Astronomers estimate there are between 100 billion and 400 billion stars in our galaxy alone. To put that in perspective, consider the human heart. Over an average lifetime, a human heart beats about 2.5 billion times. You would need 160 human lifetimes to reach the number of stars in our galaxy, heartbeat by heartbeat. Scientists understand the scale of the Milky Way by measuring the speed at which stars orbit the galactic center. By observing how fast the stars on the edge are moving, we can calculate the total mass required to keep them from flying off into the void. This calculation tells us that the Milky Way is not just a collection of lights, but a massive gravitational anchor. Most of these 400 billion stars are, again, the small red dwarfs we discussed in the neighborhood. But as we move toward the galactic center, the density increases. The suburbs where we live are quiet, but the downtown of the galaxy is a crowded, violent place where stars are packed so closely together that the night sky would be as bright as the day. What we know so far suggests that our sun is just one average star, located in a quiet, unremarkable arm of the galaxy called the Orion Spur. But even with everything we've learned, there are still things we don't fully understand. We don't know the exact number of stars in our own galaxy, and we likely never will. The reason for this is extinction, not the biological kind, but the cosmic kind. The Milky Way is filled with vast clouds of gas and interstellar dust. These clouds act like a thick fog, blocking our view of the other side of the galaxy. When we look toward the center of the Milky Way, we see a wall of darkness. Astronomers must use radio waves and infrared light to see through this fog, but even then, millions of stars remain hidden from our view. What makes this strange is that we are trying to count the residents of our own house while standing in a dark hallway with a flickering flashlight. Beyond the flat disk of the galaxy lies the halo, a spherical region that surrounds the Milky Way like a ghostly envelope. This halo contains globular clusters, which are ancient, tightly packed balls of stars. Some of these clusters contain 1 million stars in a space only a few dozen light-years across. They are some of the oldest objects in the universe, remnants from the very beginning of the galaxy's formation. Astronomers didn't expect these clusters to be so stable. They have survived for over 12 billion years, orbiting the galaxy like moths around a street lamp. but the number of stars in the halo is difficult to pin down. There are rogue stars out there as well, stars that have been kicked out of the galactic disk by gravitational interactions and are now drifting into the intergalactic void. Are they still part of the Milky Way? Or have they become citizens of the nothingness? And for now, that uncertainty is simply part of the picture. Whether there are 100 billion stars or 400 billion, the result for the human mind is the same: a sense of profound, quiet insignificance. It doesn't need to be resolved tonight. We can accept that we live in a city so large that we haven't even seen most of the buildings. The Milky Way is our home, but it is a home of such scale that we are like a single ant in a skyscraper. The 400 billion stars are not just numbers. They are potential suns, potential solar systems, and potential histories. They are the backdrop of our existence, the massive structure that holds our little solar neighborhood in place. As you contemplate the 400 billion lights of the Milky Way, let your breathing slow. Imagine the galaxy spinning slowly, majestically, taking 230 million years to complete a single rotation. We are currently on a journey around the galactic center, traveling at 500,000 miles per hour, yet the galaxy is so large that we feel perfectly still. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond our galaxy lies the local group. This is a collection of about 50 to 80 galaxies that are gravitationally bound together. While 400 billion stars in the Milky Way seemed like an ending point, it was actually just the beginning. In the local group, the Milky Way has a sister, the Andromeda Galaxy. Andromeda is larger, more massive, and contains an estimated 1 trillion stars. A trillion. That is a 1 followed by 12 zeros. If you were to count to 1 trillion, one number every second, you would not finish for 31,700 years. You would have started counting during the last ice age, before the invention of agriculture, and you would only be finishing today. Scientists understand the local group by tracking the motion of these galaxies as they slowly dance around one another. Despite the expansion of the universe, the Milky Way and Andromeda are actually moving toward each other. They are falling into each other's gravitational embrace at a speed of 250,000 miles per hour. What we know so far suggests that in about 4 billion years, these two giants will collide and merge to form a single, even larger galaxy, often nicknamed Milkomeda. This collision won't be a violent crashing of stars. Remember how much empty space there is, but a slow, beautiful blending of two massive stellar populations. The number of stars in our immediate vicinity will effectively double, but even with everything we've learned about our local group, there are still things we don't fully understand. Scattered between the Milky Way and Andromeda are dozens of dwarf galaxies. These are tiny galaxies, some containing only a few million stars. They are the pebbles scattered around the two boulders of our neighborhood. Many of these dwarf galaxies are so dim and diffuse that we are only just finding them. They are being slowly cannibalized by the Milky Way and Andromeda, their stars being stripped away and added to the larger galaxies' totals. This challenges how we think about the number of galaxies. Is a dwarf galaxy still a galaxy if it is being torn apart? How many of these tiny neighbors are still hiding in the glare of the larger ones? The local group represents a boundary. Beyond this group, the expansion of the universe is pulling galaxies away from us. But within the local group, Gravity has won. We are tied to these other galaxies for the rest of time. The trillions of stars in Andromeda, the billions in the Triangulum galaxy, and the millions in the dwarf clouds, they are all part of our cosmic tribe. And for now, that uncertainty regarding the total number of members in our group is simply part of the picture. It doesn't need to be resolved tonight. We are part of a family of galaxies, a small cluster of light in a much larger dark. As you drift further into this thought, imagine the local group as a cluster of campfires in a vast, dark tundra. Each campfire is a galaxy, and each spark in that fire is a star. There are millions of sparks, all huddling together against the encroaching cold of deep space. With that in mind, let's move outward once more, to an even larger scale. Now let's slowly expand outward. One level beyond our galaxy lies the local group. This is our cosmic neighborhood on a grander scale, a collection of about 80 galaxies huddling together in the dark. If the Milky Way was a city, the local group is the county. It spans about 10 million light-years across. Most of the members are dwarf galaxies, small clusters of a few million stars, but the group is dominated by two giants, our Milky Way and the Andromeda galaxy. Andromeda, also known as M31, is our closest major neighbor, located 2.5 million light-years away. While the Milky Way is impressive with its 400 billion stars, Andromeda is a true behemoth. Estimates suggest it contains 1 trillion stars. A trillion is 1,000 billion. If our galaxy is a city, Andromeda is a sprawling megastate. Scientists understand the local group by tracking the redshift and blue shift of these galaxies, the way their light changes as they move. What we know so far suggests that despite the overall expansion of the universe, the Milky Way and Andromeda are actually moving toward each other. They are locked in a gravitational dance that will eventually lead to a collision. But because stars are so far apart, as we learned in our human-scale anchors, the stars themselves will likely never hit each other. Instead, they will pass through like ghosts, eventually settling into a new, massive elliptical galaxy. The number of stars in our immediate clump will double, creating a sky filled with a density of light we can barely imagine. But even with everything we've learned, there are still things we don't fully understand about the local group. For years, computer models of the universe predicted that there should be thousands of small, satellite galaxies orbiting the Milky Way and Andromeda. However, when we look through our telescopes, we only find a few dozen. This is known as the missing satellite problem. Astronomers didn't expect the neighborhood to look so empty compared to their theories. Are these galaxies made of dark matter and thus invisible to our eyes? Or have they been swallowed up by the giants already? What makes this strange is that the more we look, the more we realize that our count of total stars in the local group is likely missing millions of residents who live in these dark, diffuse dwarf galaxies. These are the rural areas of our cosmic county, vast spaces where stars are few and far between, hidden in the shadows of the giants. The local group is our final anchor in the sea of expansion. Every galaxy beyond this group is moving away from us, pushed by the mysterious force of dark energy. But here, within the local group, we are held together by the familiar force of gravity. The trillions of stars in Andromeda and the billions in our own Milky Way are our permanent companions in the dark. And for now, that uncertainty about the missing satellites or the exact star count in Andromeda is simply part of the picture. It doesn't need to be resolved tonight. We are not alone in the void. We are part of a small, huddling family of galaxies. The light fades into a deep, bruised purple as the sun dips below the sharp edge of the crater. Because the atmosphere is so thin, the scattering of light is different. The sunset is blue, a cool halo around a shrinking star. The temperature begins its long, nightly plunge toward the freezing point of dry ice. The carbon dioxide in the air begins to turn to frost, a shimmering layer of white appearing on the orange rocks. This cycle repeats. The blue sun sets, the frost forms, the stars emerge in a clarity that no earthly sky can match. The constellations are familiar, yet they hang in a different arrangement against the dark. There is a sense of cosmic continuity here. The planet breathes in its cold, rhythmic way, pulling the atmosphere toward the poles in the winter and releasing it back in the summer. It is a closed system, a self-contained mystery drifting through the dark. We continue to watch. We continue to listen to the faint seismic hums of the interior, the Marsquakes that reveal the cooling of the core. The data flows in a steady, quiet stream across the millions of miles. It is a conversation held in whispers of radio waves. As one rover's battery fades, another is already descending through the thin clouds. The exploration does not have a finale. It is a permanent state of being. We are now, and will likely always be, a species that looks toward the red light in the sky and wonders about the ground beneath its dust. The wind continues its work, shifting the grains, smoothing the edges of the craters, carving the history of the future into the face of the past. The red planet remains, turning slowly in the velvet dark, a silent neighbor in the infinite neighborhood of the stars. The movement of time on this world is not a line that leads toward a conclusion, but a circle that repeats its patterns across the darkness. We observe the faint, rhythmic pulse of the atmosphere as it expands in the warmth of the sun and contracts in the chill of the night. This respiration is the heartbeat of a world that is neither fully alive nor truly dead, but existing in a state of deep, geological meditation. The hidden truth of our presence here is that we have become part of the Martian landscape. Our machines are the new boulders, our tracks are the new features, and our radio whispers are the new winds. We have integrated ourselves into the stillness of the desert, and in doing so, we have found a way to transcend the frantic pace of our own history. Imagine the perspective of the dust as it settles over the solar panels of a silent lander. It does not fall with the weight of judgment or the finality of an ending. It falls with the patience of the infinite. It covers the steel and the glass with a fine ochre veil, protecting the memories of our curiosity from the harsh glare of the stars. This accumulation is a slow, soft embrace. It tells us that there is no need to say goodbye because nothing is ever truly lost in the vacuum of space. The atoms simply rearrange themselves, the heat dissipates into the void, and the planet continues its long, steady rotation. We are drifting now into a state where the beginning and the end are the same point on a turning sphere. The stars above the Tharsis volcanoes do not seek to be known, they simply shine. They have looked down upon the rising of the mountains, and they will look down upon their eventual, slow erosion. This perspective offers a profound and gentle relief. We are no longer burdened by the need to achieve a final victory or to uncover an ultimate secret. The exploration is the secret. The act of looking out into the dark is the victory. We are part of a continuous flow of awareness, a bridge of thought that spans the distance between two worlds. As the light of the sun fades into the blue twilight of a Martian evening, we feel the continuity of the cosmos pressing in around us, a warm and heavy blanket of silence. Consider the ice at the poles, spiraling in its ancient, frozen dance. It sublimates into gas and returns as frost, a cycle that has no interest in our calendars or our clocks. This is the rhythm of the infinite. It is a process that goes on and on, driven by the tilt of the planet and the energy of a distant star. We are invited to join this rhythm, to let our thoughts become as steady and as patient as the movement of the ice. There is no urgency in the dark. There is no rush in the cold. Everything happens exactly when it must, dictated by the immutable laws of celestial mechanics. We are safe within these laws. We are held by the gravity of the sun and the rotation of the galaxy. The red horizon is a constant companion, a line that recedes as we approach it, always offering a new expanse of dust and shadow. We explain this as the geometry of a sphere, but we feel it as the limitlessness of our own curiosity. There will always be another crater to name, another rock to analyze, and another sunset to witness in its cool blue glory. The exploration is an infinite loop, a repeating melody that grows more beautiful with every turn. We find peace in this repetition. We find comfort in the knowledge that the red planet will always be there, turning in its velvet dark, waiting for us to listen once more to its seismic hums. The data stream continues, a soft and steady ticking in the background of our consciousness. It is the sound of the universe talking to itself through our instruments. We do not need to translate every word. It is enough to know that the conversation is happening. We are part of the dialogue between the matter and the light. We are the witnesses of the deep time. The transition into this final state is invisible and seamless. We are no longer listening to a story. We are the story. We are the wind shifting the grains. We are the frost forming on the basalt. We are the silent neighbors in the infinite neighborhood of the stars. The shadows on the floor of the Valles Marineris are growing long and deep, merging with the blackness of the canyon walls. The stars are emerging in their thousands, a brilliant and unblinking tapestry that stretches forever. There is no sound of a world ending, only the quiet continuation of a world being. The red planet remains. The orbit remains. The wonder remains. We are drifting now into a permanent state of celestial continuity, where the time and the space are one, and the red light in the sky is a steady, unblinking promise of the infinite. The story does not end. It merely fades into the background of the turning world, a soft and rhythmic lullaby that carries us through the dark.